Section 9.2, the parabola. So, in our Chapter 9 discussions, we're going to talk about what are called conic sections. And so a conic section is formed when a right circular cone with two parts is intersected by a plane. One of the four types of curves that can be found are a parabola, a circle, an ellipse, or a hyperbola. Today we're going to talk about the parabola. So parabolas are the intersection of a plane with one part of the cone. And so it only intersects one part of the cone. When this occurs, we're going to get one of two shapes. We're either going to get a U-shaped parabola, and it could be up or down, or we'll get a C-shaped parabola. And so it'll either look like this, or of course it could face the other direction, like this. Well, the formal definition of a parabola that we're going to use is that a parabola is the set of all points in a plane equidistant from a line called the directrix, and a point not on the line called the focus. And so check out my picture. Here we have this dotted line being the directrix, and then we have this thing called the focus. And if every point on the parabola is equidistant, recognize that that means that this length and this length must be the same. Okay, so those two lengths must be the same. Also, if you were to take this point, the distance from here and from here to here, even if it doesn't appear correct in scale in my photo, the distances will be the same. The line that is perpendicular to the directrix and contains the focus is what we're going to call the axis of symmetry. And so it's called the axis of symmetry because it is a line of symmetry between both sides of this parabola. The vertex is the midpoint of the segment between the focus and the directrix. In general, that's going to be the lowest point, highest point, farthest left point, farthest right point on one of our parabolas. That will always be our vertex. The latus rectum is the line segment passing through the focus and parallel to the directrix, connecting 2 points on the parabola. And so notice that we now have this line parallel to the directrix graphed in, and it just connects those 2 points of the parabola. So, equations of parabolas. Well, the standard form of equations for a parabola, given that HK is the vertex, if we want to talk about the U-shaped parabolas, that means it's going to either open up or open down, are going to be of the form x minus h quantity squared is equal to 4 times a times y minus k. And so specifically, we're going to know that this thing opens up if a is positive. So if a is positive, it opens up. If a is negative, it opens down. Our axis of symmetry is always going to be the x-coordinate of the vertex. So that's always going to be the line, and it needs to be in the form x equals h. A is going to be the distance from the vertex to the focus and the vertex to the directrix. And so notice that we do have to make sure we factor a 4 out of whatever the coefficient is there to make sure that we get the proper A. But once we do that, A is that distance from the vertex to the focus and from the vertex to the directrix. And so you could say that the focus is always going to be h k plus a. The directrix is going to be y equals k minus a because, of course, you take that y coordinate, shift down by the amount a, and then it's going to be a horizontal line in this situation. And then the endpoints for the latus rectum are going to be h plus minus 2a and k plus a. And so if you were to sketch this in your graph, you'll notice that what's really happening is you're shifting up from the y coordinate of the vertex amount a. That's really to the focus, right? And then you're shifting to the left and to the right. But how much? Well, because everything's equidistant between the focus and the directrix, it's going to be h plus or minus 2a. For a C-shaped parabola, changing a little bit here, notice that for the U-shaped parabola, the x stuff was squared. And so when you have the x stuff being squared, that's the U-shaped parabola. In the C-shaped parabola, it's going to look like this. We're going to have y minus k quantity squared is equal to 4 times a times x minus h. And so if the y stuff is squared, then we need to recognize that that is our C-shaped or sideways, backwards C-shaped parabola. We're going to say that it opens right if A is positive. It's going to open left if A is negative. The axis of symmetry in this instance is the horizontal line, y equals k, because k is, of course, the y-coordinate of the vertex. A is going to be the distance from the vertex to the focus and from the vertex to the directrix. That's exactly the same. The focus, though, this time is going to be h plus a, and then the y-coordinate is k. Then the directrix is going to be the vertical line, x is equal to h minus a, and the latus rectum endpoints are h plus a, and then k plus or minus 2a. Recognize that h plus a is the x-coordinate of the focus, and then we're going that distance to the right and to the left to get the pairs on the parabola. Alright, so let's start pretty easy. Given the following equations for parabolas, we want to give the direction of opening and we want to give the vertex. And so remember that our vertex is HK, and H and K align with X and Y respectively, but always remember that you have to change the sign for H and K. So, if I've got x minus 6 quantity squared is equal to y plus 4. Step 1, the easiest thing, is that we know that the vertex is 6, negative 4. Notice that I changed the sign for the negative 6, changed the sign for the positive 4. Vertex is 6, negative 4. Okay? Then, does this parabola open up, down, left, or right? Well, the x stuff is squared, so that's either up or down. But then we're looking for that a. And so if it's in the right form, the squared stuff should be all by itself on one side, and if there's any coefficients to y, that's where we get a from. But notice that there is only a 1 coefficient for y, and since it's positive, that means that this one opens up. Next one, I have x minus 4 is equal to y plus 5 quantity squared. Alright, notice that the y stuff is squared, that means it's going to open either left or right, and we can go ahead and write down our vertex. Vertex is, change our signs, 4, negative 5. Okay, great. But then the question becomes, does it open left or does it open right? Well, look for the non-squared stuff and look for the coefficient of that variable. The coefficient of x here is 1. Since the coefficient is 1, that means that this opens to the right. And maybe I should sketch these. Of course, up means that our parabola looks like this. Right means that our parabola is looking like this. Lastly, I have negative 5y is equal to x plus 2 quantity squared. Well, notice that the x stuff is squared, which means we're going to open up with either up or down. But we could go ahead and write the vertex. The vertex, change our signs, is going to be negative 2. Well, what's being added or subtracted to y? Nothing. Since nothing is being added or subtracted to y, this has a y coordinate of 0 for the vertex. And then we need to answer the question, does this open up or down? Notice that the coefficient of y is negative. Because it's negative, I can specifically say that this function opens down. And so all we have to ever do is look at the coefficients. After it's in standard form, look at the coefficient of the non-squared stuff. Alright, so now we want to find the vertex, the focus, the directrix, and the latus rectum endpoints of the parabola, and then we're going to graph it. So step 1. Maybe it's useful to go ahead and check and see if it's in standard form. Well, we have x squared stuff on one side, and then we have non-squared stuff on the other side. Notice that that is not in our standard form. Our standard form should be x minus h quantity squared is equal to 4 times a times y minus k. We're currently not in that form, so we don't get everything for free. We should adjust it. But notice that the only thing we need to do is move all the coefficients of x squared to the other side. And so I see that 1/16 is a coefficient of x squared, so I'm going to multiply both sides by 16. And then I get that this is 16y is equal to x squared. Alright, well then, if we want to get that a, just factor 4 out of the coefficient of y. So that's going to be 4 times 4 y is equal to x squared. Now this is as in standard form as it could be. Simplified standard form is of course 16y is equal to x squared, but I needed to know what a was. And so because of this, I can now tell you that a is equal to 4. Alright, but I also know my vertex. Notice that the stuff added to x squared is nothing, the stuff added to y is nothing, and so my vertex is the origin 0, 0. Then we need to find the focus. Okay, so where's the focus? Well, specifically, the focus is just going to be, notice that this function, or this parabola, actually opens up because the coefficient of y is 16. Since that's the case, and it opens up, we can really think about this practically. All I need to do is take the vertex and shift up by the amount a, and that will be the focus. And so my focus is the ordered pair 0. 0 plus 4 is 4. So that's our focus. Well then, what about directrix? Well, directrix is a line. The directrix is specifically going to be y is equal to, and then all we need to do is take the y is equal to the y coordinate of the vertex and shift down by a. So 0 minus 4 is going to be negative 4. And so now I've got the vertex, the focus, and the directrix. Wonderful. At this point, if we're trying to find the lattice rectum endpoints, think about this practically. It's the focus where we go a little bit to the left some amount and a little bit to the right some amount. Well, how much? Specifically to the left and right 2 times A. And so those will actually be good ordered pairs for us to plot. So they are, once again, H plus 2A, K plus A, and really this is plus and minus 2A, right? Because you go a little to the left and a little to the right. So then, K plus A for the focus is 4. Well, then I just need to go to the left of the focus by 2 times A, but 2 times A is 8. And so 0 minus 8 is negative 8. And then 0 plus 8 is positive 8. And so I claim we have plenty of information to graph this. Unless we are asked, I'm not going to graph the focus, the directrix, or the lattice rectum. I'm only going to use the endpoints of the lattice rectum because those are points on the parabola. The vertex is a point on the parabola. And so we can graph the vertex and the endpoints of the lattice rectum. 8, 4, negative 8, 4. And I claim that if I can connect the dots properly, this is a sketch of our parabola. Let's do it again. We have negative 2 times y minus 6 is equal to x minus 5 quantity squared. Well, we're already in standard form. This is good. And since we're just graphing the parabola, I'm going to try to help us get some easy values here. I'm looking for whole numbers just to make my life better, but recognize that if we want to graph the parabola, of course we need to find the vertex first. And the vertex here is going to be 5, 6. Remember, you change the signs. But then I'm going to adjust this and just plug in some values, or at least observe and see if I can think of some nice values. And so if I divide by negative 2, this is going to be y minus 6 is equal to negative 1/2 is equal to x minus 5 quantity squared. Y minus 6 is equal to, divide by negative 2, negative 1/2 times x minus 5 quantity squared. And then I'm going to add 6, y is equal to negative 1/2 times x minus 5 quantity squared plus 6. Well, honestly, all I'm really hoping for here is that if I can take something that subtract 5 squared gives me an even number, then if I multiply it times 1/2, it will give me a whole number. I'm just trying to doing this for preference. But also, I want values to be close to 5. I'm actually thinking, why don't I plug in 3? Because if I plug in 3 minus 5 will be negative 2. Negative 2 quantity squared is 4. So, other points. So let's find them. I'm going to let x equal 3. And so then, negative 1/2 times 3 minus 5 quantity squared plus 6. But that's going to give me negative 1/2. 3 minus 5 is negative 2. Negative 2 quantity squared plus 6, but negative 2 quantity squared is 4. 4 times negative 1/2 is negative 2. Negative 2 plus 6 is then going to give me positive 4. And so I get a second point. That's going to be 3, 4. Alright, so let's graph that vertex, 5, 6. Then let's graph our second point, 3, 4. Now notice that this was working out the way I hoped because the vertex should be the highest point and this parabola should open down due to that negative 2 up there. Now, at this point, I'm actually going to save myself some time. I recall that there's this thing called the axis of symmetry that passes through the vertex. If it passes through the vertex, then if I look, this point being 1, 2 to the left, I get a mirror point 1, 2 to the right. And so I can save myself a moment, use these two values, and I claim that now we have this parabola. Now I'm not sure where it crosses the x-axis, but if we desired we could find out. But as far as I'm concerned, we found the vertex and 2 more points and graphed them. Do be careful because MyLabs is going to specifically sometimes ask for certain values to graph with, and so if they tell you that you must graph with the endpoints of the lattice rectum, you probably need to do exactly that. Alright, so now we're going to change it up a little bit. We want to find an equation of the parabola with vertex 0, 0 and focus negative 3, 0. Now, if it helps you, why don't you sketch what you're told? So if we know that the vertex is 0, 0, and then we know that the focus is negative 3, 0. Okay, 1, 2, 3. All right, now the reason I went ahead and sketched that is because then I know where my directrix is. My directrix is opposite the vertex, and it's a vertical line. And so I know that before I go even further, I know that this parabola is going to look something like this. Has to. I don't have a choice here. Because it must wrap around the focus, and then it's equidistance between the directrix and the focus, well, that's the sketch. Well, why did I do all that? Because then when I'm considering which standard form I want to work with, I know that it's C-shaped, therefore I know that it's going to be y minus k, quantity squared, is equal to 4 times a, equal to 4a times x minus h. And so this is going to be the standard form of my equation. Well, what can we get from what we have? Well, we know what the vertex is, right? The vertex is 0, 0, which means that hk is 0, 0. Great. Getting even better, that means that my equation is actually y minus 0 is just y, quantity squared, is equal to 4ax. Oh, this is getting even better. But then, what about a? Well, remember that a is specifically the distance between the vertex and the focus. Because our focus is negative 3, I know that negative 3 is equal to our h plus a, but since I know that h is 0, I know that negative 3 is equal to a. And so now I have that the equation y squared is equal to 4 times negative 3 times x, or specifically y squared is equal to negative 12x. And so now I have an equation for this parabola. It didn't ask for me to sketch it. My sketch is definitely not to scale. Do not trust where the ordered pairs I've put are. I just wanted to try to make sure that everything worked out how I hoped, and that's the only reason I even sketched it on that picture. Now we want to find an equation of the parabola with the focus 6, 1 and the directrix x equals negative 7. Alright, x equals negative 7. Our directrix is a vertical line. And our focus is 6, positive 6, 1. Okay, so right here. This is the focus. Okay, couple things. If we know the directrix and we know the focus, we know the vertex. How? We know that the vertex is halfway between the directrix and the focus, or specifically, if you picked this point on the directrix, then you could take the midpoint between those 2 points. And so since I know the focus is 6, 1, and a matching point on the directrix is negative 7, 1, if I wanted to know what is the vertex, then I'm going to take the midpoint. That's going to be, recall that the midpoint formula is really just the averages of the x's and the y's. And so that's going to be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So we're just finding the average of these values. And so the midpoint's then going to be 6 plus negative 7 divided by 2. And the y is going to be 1 plus 1 divided by 2. Once again, notice that I've picked another point on the directrix in the same y value in this instance because I see that this is going to be a C-shaped parabola, which means that my midpoint or my vertex is going to be negative 1/2, 1. And so I know that this is my vertex right here. Okay. So if that's the case, notice that this is C-shaped, and so C-shaped means that this is going to be y minus k, quantity squared, is equal to 4a times x minus h. And so now we know that h and k are negative 1/2, 1, or so this is going to be y minus 1 quantity squared is equal to 4a times x minus a half. Alright, so let's think about our a. Well, our a is just going to be the distance between our vertex and our focus, or our vertex and our directrix. But specifically use focus, that way it fixes the positives and the negatives. Now honestly, I think we can count this. 1, 2, 3, 4, 5, 6.5. That's what a should be. A should be 6.5. 6 1/2, but mixed number notation is one of the most misleading notations, and so this is really 13 halves. Now let's confirm that. If you would rather, you could have used the distance formula. You could have taken the distance between the directrix and the focus, squared it, square rooted it, and divided by 2 to confirm, but I claim since it lined up so nicely, we were perfectly fine. And so then our formula for our equation is specifically going to be y minus 1 quantity squared is equal to 4 times 13 halves times x plus a half. And if you wanted to clean up this 4 times 13 halves, that's going to be y minus 1 quantity squared is equal to 26. 4 divided by 2 is 2. 2 times 13 is 26 times x plus a half. And so there's our equation. Well, now we have a little more work involved. So now I've got y squared minus 2y minus 6x minus 31 is equal to 0. Notice that this is currently not in standard form. And so we need to find the vertex, the focus, the directrix, and the latus rectum endpoints, and then we need to draw the graph. But before we can do that, standard form is necessary. So what are we going to do? Well, we're really going to complete the square after putting everything that's not a y term on the right-hand side. And so this is going to be, I'm going to go ahead and add 8x, add 8x, add 31, add 31. We're then going to get y squared minus 2y, leave some space, is equal to 8x plus 31. But then to complete the square, we add b over 2 squared, which is going to be negative 2 over 2 quantity squared. Add it to both sides, add negative 2 over 2 quantity squared. But now this factors nicely. This is then going to give me y minus 1 quantity squared is equal to 8x plus 31 plus negative 1 quantity squared, but negative 1 quantity squared is just positive 1, and so this really gives me 32. Well, so then I get y minus 1 quantity squared is equal to 8x plus 32. Recognize we're still not exactly in our standard form that we've seen. So what are we going to do? Well, we factor out the coefficient of x. So the coefficient of x is 8. So this is then going to be y minus 1 quantity squared is equal to 8 times x plus, well, what's 32 divided by 8? 32 divided by 8 is 4. And then recognize that we can also find that this is really 8. Factor out of 4 of 8, that's going to be 4 times 2 times x plus 4. And so I've found multiple things. I now know that a is 2, because factor out the 4. Then I know that my vertex is going to be the ordered pair, negative 4, positive 1. Remember to change your signs. Which then I know that my focus, because this is y stuff squared, and the coefficient of the x stuff is positive, this actually opens to the right. And so since this opens to the right, the focus is going to be shift the vertex point to the right by 2, which means it's going to be negative 2, 1. And then if we want to find the directrix, well, that's going to be the vertical line, so it's going to be x equals. And so go back to the vertex and shift your points to the left by 2. And so that's going to be x is equal to negative 4 minus 2, or negative 6. Lastly, I need to find the endpoints of the latus rectum. And so for this one, we're just going to start with our focus. And then because the focus is to the right of our vertex, and if you want, let's go ahead and sketch our vertex to keep us on track. Negative 4, 1. Well, the focus is at negative 2, 1. So I'm just going to put that dot there to keep me on track for a moment. So really all I need to do is shift up from that focus value 2 times a. And so since a is 2, the endpoints of the latus rectum for this specific version are going to be the x value of the focus, which is h plus a, and then the y value of the focus, shifted up by 2 times a and shifted down by 2a. Well, h plus a is negative 2, right? But then k, that's going to be 1 plus 2 times 2, right? Because a is 2. So that's going to be 1 plus 2 times 2, and negative 2, 1 minus 2 times 2. And so I get that these endpoints are negative 2, shift up by 4, 1, 2, 3, 4, 1, 2, 3, 4, and so specifically they are 5 and -2, -3. Well, once you've graphed the vertex and the endpoints of the lattice rectum, that's 2 points on the parabola, and so I claim that this sketch of the parabola is enough for us to see what's happening. I'm not crossing the y-axis at this point because we weren't told to find the y-intercepts, and so I don't want to misrepresent them. When you're graphing using MyLabs or the computer system, you're going to be just fine. Okay? So let's do it again. If we have the parabola x squared minus 4x minus 4y is equal to 0, we want to first rewrite it in standard form. So notice that my x stuff is squared, so I'm going to add 4y to both sides. Add 4y to both sides. This is x squared minus 4x, leave some space, is equal to 4y. Add b over 2 squared to both sides. -4 over 2 quantity squared. Add -4 over 2 quantity squared. So then what do we get? Well, this factors nicely as x minus 2 quantity squared is equal to 4y plus -4 divided by 2 is -2. -2 quantity squared is 4. So then I can factor further. This is then going to be x minus 2 quantity squared is equal to 4 times y plus 1. At this point, recognize that our vertex is 2, -1, and recognize that with 4 is already factored out. And so what times 4 gives us 4? Well, 1, and so we also know that a is equal to 1, which means that we know what our focus is. Our focus is then going to be the vertex, and since the x stuff is squared, we recognize that this opens up. The focus is going to be shifted up by 1 from the vertex, and so that's going to be 2. -1 plus 1 is 0. Well, what's the directrix? The directrix is going to be the line y equals, go from the vertex and shift down by 1, and so that's going to be -1 minus 1, or -2. And then the lattice rectum endpoints, they're going to be moved from the focus a distance of 2a to the right and 2a to the left, and so that's going to be 0, 0 is to the left 2 times a, 2 minus 2, and then shift to the right a distance of 2, so that's going to be 2 plus 2, or 4, 0. Then I can draw this graph. My vertex is 2, -1. My lattice rectum endpoints are 0, 0, and 4, 0. And so then, there's my parabola. An example problem. A satellite dish is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 10 feet across at its opening and 4 feet deep at its center, draw a sketch of this satellite. You may use the origin as the vertex and the focus on the positive y-axis. And so we want to figure out at what position should the receiver be placed, that is, where is the focus. Okay, so what can we do? Well, let's just sketch ourselves a graph. And so I'm going to make my life easy because I was told that I can use the vertex at the origin 0, 0. And then if this opens like this, I know that my focus is going to be somewhere on the positive y-axis. Now, what else are we told? We are specifically told that this satellite that I've drawn, it actually terminates here and here. Okay. Now, when we deal with our function to find our focus, we might ignore that it terminates, but for the moment, it's going to be useful. So at its center, this satellite has a width of 10 feet across. So from here to here is 10 feet, which means that this is at 5, and this is at 5. And then we're also told that it's 4 feet deep. And so the distance from here to here is 4 feet, which means that here is 4 feet. And so then this ordered pair on our satellite is going to be the ordered pair 5, 4. And this ordered pair on the satellite is going to be -5, 4. Okay, I think we have enough information. The good news is that our vertex is 0, 0. So let's write the standard form of the equation for our graph here. this is going to be x squared is equal to 4ay. Okay, I claim that the information we've been given is enough to get us to find a. So, what can we plug in? Well, we can plug in 5, 4, or we can plug in negative 5, 4. Remember, just plugging in x and y values. Okay, so let's try this. I'm just going to plug in 5, 4 first, so this is going to be 5 squared is equal to 4 times a times 4. Well, 4 times 4 is 16, so 25 is equal to 16 times a. So we can divide by 16, divide by 16, and so a is going to be 25 sixteenths. Then, since we know the standard form of a parabola, and we know that a is 25 sixteenths, specifically, we know what distance from the vertex the focus exists. Specifically, the focus exists 25 sixteenths of a foot above the origin. And so, 25 sixteenths of a foot above the center is where the receiver should go, which is 1 9/16 feet, if you would rather, or 1.5625 feet. A few other examples of applications of parabolas are going to be cross-sections of car headlights and flashlights. That is, the bulb lets off that light and then the parabola refocuses it. Also, like we just saw, cross-sections of satellite dishes, field microphones, incoming radio waves or sound waves parallel to the axis of symmetry are reflected into the focus. We can see that cables hung between structures and suspension bridges, such as the Golden Gate Bridge, are parabolic, and that is some more examples of parabolas.